Okay, who is ready for the Intelligent Cooperation panel? This is definitely going to be a really spicy one. And I'm really excited to have a fantastic group to be discussing very thorny issues with. I would love to welcome up on stage Marta Belcher. Please come up here. Peter Norvig, Nathan Lile, Anton Troynikov, and PJ Maykish. Please take a seat. Before we dim the lights here on the panel, I want to read you out again a quote. This is from Eric Drexler and Mark Miller in the Goric Open Systems papers. Mark is a senior fellow at Foresight. And they said, with many minds building knowledge and competence into market objects and with incentives favoring cooperation among these objects, the overall problem-solving ability of the system can be expected to grow rapidly. So let's see what we can make of this in the realm of cryptography, security, AI, and related technologies. Really excited to have a wonderful panel here. Marta has also been a repeat guest at Foresight. If you want to hear a little bit more about what she has to say, we have the Intelligent Cooperation workshop report out there where she's also in. Peter, he's no introduction. He's been really at the forefront of computing and AI and has been writing textbook like there's no tomorrow. We have PJ, who you already heard from SCSP. And then over there, we have the wonderful Anton Troynikov and Nathan Lile. Thank you so much for coming and joining us here. I think this is going to be quite the wild ride. All right, thank you very much. Wonderful. So first things first, again, maybe let's start with a bit of an intro into this field. And specifically, I mean, you all work on different, really different aspects of the whole shebangs that we call intelligent cooperation across humans and AIs. So could you bring us up to speed a little bit on, like, you know, how has your work really shifted, and like what are you really excited about, like in the next 5 to 10 years? Like what is one technology, if you had to highlight one, or one development that you really want to bring forward and make an opening statement with?
Great. Awesome. Well, thank you for the mood lighting. I appreciate it. So I would say I'm with the Filecoin Foundation. For us, one of the things that's been really exciting about looking at AI is we've been really looking at the ways in which the internet has really come to a place where you live your entire life through just a handful of corporations. What we're really excited about is building technologies on top of Filecoin and in the same way as Filecoin that actually enable decentralized computation, so that when it comes to AI, we don't have a future where the entirety of the field is really in just a few powerful players' hands.
That's a great opening statement. Peter's already getting a call here.
Hi, I'm Peter Norvig from Google and Stanford. I'm the AI hipster. I was doing it before it was cool, going back to the 1980s. And back then, we were doing natural language processing, and we thought it was going to be really hard. You need lots of different components. And it turned out all you had to do was have it read a lot of text. And that was very surprising that worked so well. To me, it's an amazing technology, and the amazing technology is not so much transformer networks, it's language. I kind of thought language is a cool invention, but most of what's going on is in the head of the listener or reader, not so much in the text itself. And it turns out there's more in the text than we thought. So that was a big surprise to me. And the other big surprise to me was not only are these systems so good, but I never would have thought that a system that's so good could also be so bad. I would have thought that, you know, if you can answer all these things correctly, that you probably wouldn't make all these crazy bad mistakes. But that's where we are, and so it's up to us to figure it out. So where are we going? I think, you know, this last year has been the year of large language models. I think the next year we'll be moving more into multimodal and into tool use, into working with APIs and third-party tools. And I think over the course of several years, we'll see a new platform emerge. You only get so many platforms. We went from mainframes to PCs to mobile, and now maybe it's large language models interacting with each other will be the next platform.
Fantastic. Thank you, Peter. Allison, we're excited about how things are combining across the AI stack. So there are some AI engineers present, but just in case you're not, you know, AI across a stack is data used on a computer with a list of instructions, algorithms that produces applications that get integrated into the real world, and there's a talent pool for each one of those. So the AI stack is not just the app, it's the stack. But if you study the stack and think of AI strategy, there are innovations happening in each part of that stack. And so I think as we look through intelligent cooperation through these 5 lenses, and through the lenses of everyone gathered, I think you're going to see some really beautiful things happening there. There are 9 specific things in my mind. Peter just mentioned one of them that are just in the algorithm layer itself. Things like reflection and things like, which gives the ability of the computer to have a form of memory and to do its own reasoning trace to answer a question that you give it better, down to something called community of experts, which is the ability to orchestrate not GPT-4, but up to 700 specialized models that act in concert as one. That's here today. That's already being done by a company called Sambanova. So if you just look at the innovations happening in each silo of the stack, it's coming, more general AI is coming fast and coming soon. And I think we should be excited.
Yeah, thanks. There's a lot to be excited about around intelligent cooperation, and I think I actually want to speak to part of the dual of what Professor Norvig was saying, which is great, the models have started working, but they work in really strange ways, right? I think that was such a great way to phrase it. You would think that if they were so good at the things they're good at, nobody would have expected them to be so bad at the things they're bad at. And I think what that really speaks to is we haven't before been able to understand the function of these systems because of the way that they're created. You know, we train models under general purpose optimizers where they teach them to learn to read text. But the internals of these models have been sort of considered inscrutable or incomprehensible. Now, me and my co-founder founded our company Chroma on the idea that actually you can understand the behavior and performance of these models from an engineering perspective. And over the last 6 to 12 months, and this just keeps happening, we've had really great breakthroughs in understanding not only how these models work from an engineering perspective and what trade-offs we make, but from a fundamental theoretical perspective as well. Like recently there was a paper from Professor Yi Ma out of Berkeley, which basically maps the idea of sparse coding onto the transformer network. And that's really a great breakthrough because we understand sparse coding. We can work with that as a mathematical model for what these models are doing. And so that broad category is called interpretability. It's called sort of, it's broadly part of AI alignment, but I think that work is necessary and critical for us to build safe, robust, understandable performance systems, and they will enable the next breakthrough beyond just training models at larger scale if we can understand how they work and why. So I'm tremendously excited about that.
Hey, I'm Nathan Lile, and I think Anton was the perfect intro to what we're excited to be working on as well. And also thank you, Allison, for organizing such an incredible event. I was previously at Stability AI, where we were training state-of-the-art foundation models for all modalities, best known for Stable Diffusion, the text-to-image model. While I was there, I became increasingly passionate about interpretability, about alignment from a functional standpoint, and started to become increasingly passionate about exploring these areas. So recently founded and the CEO of a brand new RL lab for reinforcement learning, because we realized what are we aligning these models to? There's basically no work that's been done on interpretability of reward models. It's very, very difficult to tell exactly what RLHF is doing. We just know that it makes it ChatGPT from GPT-3. We are excited to be doing deep research in some of the areas that are still unanswered and unexplored by the frontier companies like OpenAI and Anthropic. And I think some of the tools that we have right now are very empirical. And from that starting point, I'm incredibly optimistic about synthetic data, about using AI to continuously iterate and produce really high quality evaluations, red teaming, and stress testing.
Wonderful. I also want to mention that if you guys want to chime in on anything else that someone else said, just go for it. It can be as informal as you make it. Yeah, go for it.
Yeah, I want to say something. So I love the idea of synthetic data, and one of the things I've been thinking about is we haven't done a great job of saying, let's take these models that we built just by learning and combining them with a sort of structured model, a physics-based model or whatever, that's just hard to do technically. And I think synthetic data is the way to do it. To say, we can't put the model in the loop, but we can have the sort of physics model generate the synthetic data and use that as training. And so I think that's, in the short term, that'll be the way that we combine these symbolic and neural networks is through synthetic data.
Yeah, I mean, I couldn't agree more. I think we really have not tapped into the amount of potential structured data that we can generate that can really improve reasoning. Step-by-step reasoning is incredibly optimistic for pre-training with that data. But also inference time search and figuring out how to draw out capabilities, that's been really important. We've seen distillation through that type of approach. And it's really highlighting how inefficient some of these models are today and how much we can distill them and boil them down.
Wonderful. Well, I think we've heard a little bit now about some of the promises, and of course, I think let's address perhaps now immediately the elephant in the room. Like, I'd love to know if you have a little bit more of a nuanced perspective than AI doom or like a wildly positive view on AI. Are there specific things you're worried about? Like, is it like AI accelerating biorisk or computer insecurities or human rights violations or what have you? Like, what's your more nuanced position in that? Or maybe it is just totally clear cut and polarized in one way. Anyone? Feel free to start.
I mean, I can start on this one. I feel like this is a very Anton question to be asked. My kind of middle of the road thinking around this is fundamentally AI is going to be more boring than you expect, whichever end of that spectrum you're on. The reality is that a lot of our projections forward about what AI can do for us are speculative in both the positive and negative contexts. And then when you encounter the reality of dealing with these real systems and start thinking about where they can actually be applied, it looks a lot more like the standard iterative empirical engineering work undergirded by good theory that eventually brings these things to be useful systems that we deploy where they're useful and we don't deploy where they're unsafe or not useful. I just think that the future is, unfortunately or fortunately, depending on which side of the fence you're on, going to be more boring than people expect.
Spicy take. Anyone here to disagree here?
Yeah, I just think that if you look at some of the AI applications already, we've tried to make a list of the greatest hits to say, that's true this year. Suppose that GPT-10, let's use it for the sake of analogy, is better, and you keep going on. If you just look at the computer science fronts that are combining with large language models right now, and let's just name a few. We started to before. Peter, you started to name some as well. We've both named some of them here, but let's just add them, because they're going to combine in algorithm families that operate in a single platform. So we all know that the grounded search piece is what Sundar Pichai said is yet to come. He has said, I have an AI application that can do planning, reasoning, and grounded to search. So giving an AI algorithm the ability to kind of do its own personal research. We know that the AIs have had an ability to do some coding, and that's gone way past GitHub now to AlphaCode, which can outperform a human with 5,000 experts 50% of the time. So that was like 2020 in terms of just being able to code its way out of problems. I mentioned reflection, but if you haven't seen it yet, there is a TED Talk about how GPT-4 will combine with all of Khan Academy. So all of Khan Academy is now working with the GPT-4, it's called Khanmigo, that would train a student in something like linear algebra and interact with them. And in the TED Talk, you will see the system is doing reflection. So it is what is happening beyond the scenes about how the AI algorithm is thinking about how to answer the question before it does. Now you can interrogate that and say, what are 5 better ways to answer this question? But it's doing that now. I mentioned community of experts. That's the ability to orchestrate more than one trained model. You might think of one model devoted to all the sciences operating as one. That's done science. That's here. So I think somewhere in between where, doom and these are the fronts that are combining with it now. We just haven't seen it. The next thing, and I'll stop, that you're going to see is tree search combined through Gemini. And so the team that created AlphaGo, which was so 2016, that combined tree search to defeat humans in Go is now combining that with LLMs at Google. They're also adding memory and ability to do attention modeling. That's now. So Gemini's coming out this year. So I would just say, if you look at the fronts, we got to think about just what is now to suppose where it's going to be even next year.
Can I push back a little bit on this?
Please.
Because there's a part of this, and this is honestly kind of the original sin of computer science, as far as I'm concerned. We tricked ourselves by using the wrong metaphors for systems of logic, by saying the machine is thinking, by saying the machine remembers, by saying the machine is reasoning. This is not what these systems are doing. The system is not reflecting. It's producing output that a human brain would interpret another human as reflecting, but there is nothing in a transformer that behaves like the human brain does. There is nothing in a transformer that behaves like the human mind does. It is at best emulating the output of the human cognitive process, and it's not doing it very well, and that's going to improve.
Totally agreed.
But I think this is actually something that worries me. This is a danger. Because if we keep projecting these metaphors onto these systems, we are not going to be able to think through them appropriately. We are not going to be able to think through them as engineering realized concrete systems. And for me, that's dangerous. And frankly, you want me to get spicy with this, the far future version of this is we mistake a artificial intelligence that we build for a person and we give it legal personhood. And on that day, I'm going to move to a cabin in Montana.
I just want to say briefly, anthropomorphizing the processes of a computer, valid, is a danger. Completely agree.
You shouldn't anthropomorphize those computers. They hate it when you do that. I guess I wanted to say a couple things I'm concerned about. And one really has to do with software, not just AI, but AI is becoming a more important part of software. And that's it. When you have goods with zero marginal cost of reproduction, you tend to have concentration of income. And I think that's a threat to our society, and we have to learn how to deal with that. Then the other is Goodhart's law that we build all these systems to optimize some objective function based on data. And when you do that, you tend to poison the data, that you skew things in order to reach that optimization function, and now the objective is no good anymore. And trying to keep ahead of that as we put more and more emphasis on this cycle of measuring and repeating, I think that's going to be difficult.
For me, the thing that I'm really worried about, I'm pretty optimistic about AI as a technology, but I'm really concerned about what the reaction to AI will do to important legal precedents that are very hard fought, that because a lot of people see a lot of potential doom in this technology are sort of getting railroaded. So to give you a few examples, first really important example is about the way in which data is ingested into these models. For some reason, a lot of people look at that and say, well, actually, that shouldn't be allowed. These technologies shouldn't be out there and able to learn from this data that's openly available on the web, right? But if you think about that in a different context than AI, I mean, Google would not be able to exist. All of the open web would not be able to exist without the ability to do that. And that is a very hard-fought legal precedent, right? And one that is at stake right now in many, many cases where AI companies are being sued for copyright infringement merely because their models have gone out and learned things. So that's one place where this technology, I think, could lead to really setting us back with legal precedent. Another is when you're talking about regulating AI. I think people get so nervous about the technology that they're willing to do things that they otherwise wouldn't see as being reasonable. There's some really important precedents in the US that are very important for civil liberties. One of them is that code is protected speech and that writing code is protected by the First Amendment. When you see people sitting down and hashing out what they think these regulations should should look like. Often it involves penalizing people for merely writing code. When I hear people talk about regulating GPUs, right, all that will do is really centralize the power into a few powerful hands and really lead to a more authoritarian world. And at the same time, it really reminds me of the original crypto wars, right, when encryption was in fact seen in the same way and regulated like a weapon. So I'm really worried about those legal precedents.
Yeah, I think I'm going to springboard off of decentralization being incredibly important here. But we have a new type of technology that we need to decentralize. And if you think about how much time some people spend on TikTok getting sucked into a very personal algorithm, I think there's a whole lot more where that came from when you apply an AI that might not be aligned for your best interest. It might be aligned for your attention. And so I think decentralizing these models, I want my model on my device. I want to align it with my objectives. And to Peter's point earlier, I think from a lower level technology standpoint or a research perspective, Goodhart's law is a big challenge. And there's a huge amount of work to do there. And it's not necessarily super exciting or fun, but we need to continue to get people excited about solving these really hard problems.
Oh, great. Well, let's talk about a few possible solutions. Like I think, we usually host this annual event bringing together people in the cryptography, security, and AI-related worlds together to try to bridge build a little bit more across these different worlds, because we do think that security and cryptography as well and auxiliary fields have like a lot to contribute potentially to like making AI safe, making it like making it aligned with us, and also creating really wonderful new applications in that space. So if you were to had to pinpoint like a specific technology like that you think is possibly undervalued, that you would like people to focus on more, is there one? It doesn't have to be from cryptography or security or any of these fields, but is there one that you're like, well, that's one we should be betting on more?
Yeah, I mean, if we're talking about investing in basic technologies, I think we have a habit now of believing that research breakthroughs can only come through very large investments. But the reality is, I think that I fundamentally don't agree with like Tyler Cowen's low-hanging fruit thesis. I think it's bullshit. I think that there's plenty of incredibly important basic research in fields like mathematics and computer science, which costs almost nothing to do, which could have enormous impact in AI and then beyond, in material science, in pretty much everything. And I think that those opportunities are being overlooked, and there's not really a place for them today. Now, to sort of tie it back to the purpose of this panel, I think actually this is something where AI technologies could be incredibly useful, because if everybody could, and Peter, we were talking about this a minute ago, but if everybody could just get a PhD in a box on any topic that they could possibly want to learn, then the number of people who can reach the research front just explodes immediately. And in fact, that makes humanity better suited to solving problems, because our kind of species level reaction time gets smaller and smaller and smaller until we can adapt to crises as fast as possible. But yeah, basically I would say like basic investment, cheap investment in things like literally just pay a mathematician to keep doing math instead of becoming a quant trader, right? That's huge alpha in that.
Don't be shy, you guys.
Yeah, I'm gonna shut it down.
Okay. So for me, I think the technology that I'm most excited about is decentralized compute. I think that the decentralization piece is really difficult with AI because it's so GPU intensive, right? And if you want to be able to build this technology in a way that doesn't just lead to a few companies really dominating what our day-to-day interactions are like what we're seeing. I think you need to be able to do it in a decentralized way, and you have to, for that, have decentralized compute. So that's something we're really focusing on in the Filecoin ecosystem. Well, so with Filecoin, the idea is for storage, we've created like Airbnb for file storage, right? So people all over the world are putting their storage capacity onto a network, and those all sort of combine into something that looks like and feels like an AWS, but in fact is computers all over the world. And it's even better because you don't have the availability of information dependent on any one server or company. You can have hundreds of copies all over. And similarly, you can take that same model that we've used for storage and actually do that, insert where you say storage capacity, insert GPUs.
Yeah, and I think there's been some recent work lately, Marco Aurelio Ronzato and others, on doing distributed computing on a single model by having very low bandwidth communication, right? So we sort of thought up to now the model is you get thousands of GPUs in one data center and they have to communicate very tightly. But we now see that there are ways to do that with much less communication by breaking up the network into pieces and doing a clever job of searching through the possible space. And so I think that opens it up for smaller companies without the big budget, and more particularly universities, to say, a consortium of 20 universities could go together and say, we've got a little bit of computing each, we're going to pool it all, we can build one model across our sites, and we have enough communication to make that be effective.
Cool, wonderful. Anyone else want to chime in?
I was just going to say, there's an enormous amount of research and work that can be done that I'm optimistic about that doesn't need GPUs, but it ties back, and that's within evaluations. We do not have good evaluations or benchmarks today. Most of that ends up inside of the models to an extent. A lot of it gets fine-tuned in. And if you're kind of deep in this space, what you realize is that you have to actually pull the model, play with it for a while before you form an opinion on how good is this model, and then where does it fail. And the problem here too is wherever it fails, you might be one of the few people that's found that failure or even cares about it. So I think we're going to see a lot of increasing specialization within the last mile, let's say, of model customization to really scope these down to your use case. And it does not require a ton of GPUs. And then, like I said, evaluations, I think everyone should be kind of first and foremost focused on that if they're interested and don't have access to compute.
And I wanted to add, this is not the first time that we've had an industry that's very capital intensive, but we still needed the research, right? So universities have had civil engineering departments for many, many decades, and they never get to build a skyscraper, but they contribute to the overall development of the field.
I would just add technology interests in this space would be good AI that counters bad AI. We've published 3 examples of what we would regard as bad AI, which would be autonomous disinformation systems that could automate polarization in society. The seminal work on that was called The Machine-Driven Communication Future, written in 2017. But we think that future is actually already here. And then the second one is that AI applied to autonomous attack and defense systems has been opening at DARPA since 2016. There was a challenge to do that. So what does it look like to have good AI sort of recognize and detect those kinds of attacks on infrastructure? And the third would be AI applied to something like an integrated missile defense shield for Pathogen Plus. We've called this Med Shield. It has 5 basic technical areas, which is to improve surveillance with AI of Pathogen Plus, and then rapid vaccination, rapid therapeutics, advanced modeling and simulation. For now, we'll just use as a thought experiment like Gemini applied to those 3 fields, and then finally, AI applied to rapid manufacturing of those solutions. That looks like a shield. So that's good AI to counter bad AI are places that we would like to see things go.
Yeah, I love that. If you do you have any specific really positive use case, let alone let's say how we can let's say create more safer AI solutions, but I would love to see much more what AI can do for science and tech, right? I think one of the things every one of our technology tracks has been totally revolutionized, I think, with many of the different AI tools that have been coming on. But then mostly in our AI track, that's where people are like, oh God, damn, where are we going to go? And through the other fields, it's such a massive improvement of how science is done. Do you have any specific other areas that you want to pinpoint to or want to highlight of what you're excited about in particular being potentially just advanced a little bit better?
So is the question about how we expect AI might improve?
Is there a specific field? You know, like
Yeah.
for me, for example, it's like, I guess, science across the board, especially
Gotcha.
in longevity biotech, but also molecular modeling that I'm
Gotcha.
super excited about. But are there specific bits where you're like, wow, this
Yes.
is very, very exciting?
Yeah. Would you like to know my dream for AI? Would you like to
Give
know
us
the
your
thing
dream.
that I would die happy if I saw it happen? In game 2 of AlphaGo's game against Lile, it played the famous move 37. That's right, move 37. And move 37 was a move that completely surprised the competitive Go community. Now, of course, the headline was, superhuman Go machine defeats the best human player in the world. It's over. Nobody will play Go ever again, obviously. The reality of what happened in the Go community after move 37, and in fact in studying AlphaGo's play even after the Lile games, the sort of competitive Go community, they play online, and one of the metrics that they track is novelty in their games. In other words, the novelty of any given position reached. And after these results, basically after AlphaGo, the novelty spiked almost immediately. People started learning new ways to play this game, which is incredibly ancient, right? Now, I like Go. I'm not good at Go. I've played it. But what I am very excited about is mathematics. And what I would like to see in my lifetime is a move 37 for math. I would like to see an AI assist human reasoning to have a new perspective on logic and foundations of mathematics, or in fact any kind of mathematical insight that was just laying around in plain sight, that we could have picked up at any time, but it took this thing that operates like this perfect empiricist, like an almost alien intelligence, and it helps us find new ways as humans to reason. Computer proofs on their own are not very enlightening because they don't come with explanations. So an AI that helps us reach a new explanation in something as foundational as mathematics, I could die happy.
Love it.
Let me jump in there and say, I think it's interesting that for AlphaGo, there were Go experts on the team at DeepMind. And then they came up with AlphaZero, where there were no experts involved at all. It was only self-play. And it could play Go and chess and other games at Grandmaster level. Now, they've hired the experts back to try to explain what it is that these systems have learned, right? So you can teach another chess player not just this one move 37 in this one situation, but here's the general principle behind it. And the humans are still needed to come up with those explanations.
Anyone else want to add something that you're a field that you think will be revolutionized?
I mean, I said it briefly, but if the internet changed access to knowledge, it looks like it's possible that AI could change the way education happens. It could democratize it. It could spread it to rural areas. It could spread it to basically anywhere there's connectivity. So there is this thought that if you've been in Khan Academy, if you've seen it, and the ability to actually self-tutor you, and now it's sort of AI enabled, but that is reaching age-appropriate people at any place that they're doing a subject on Khan, that's exciting, that you could improve the collective education of the world this way without overcooking it. That's exciting.
I would really love to believe in that future, and I am very excited about the application of AI in education, but the reality of almost every media technology we've ever created as human beings is we've always been excited for its potential for education, but it mostly gets utilized for propaganda and pornography, so...
Khan Academy is being used, so there is a counter.
I have a slightly spicy take, which is that one thing I'm actually really excited about with AI is the way that it could really proliferate the use of cryptocurrencies. Because if you think about it, a lot of what AI is, will have to do out in the world is exchange value in order to do certain things, and they're not going to go get bank accounts, right? So what are they going to use to exchange value? It's going to be cryptocurrency.
So I guess I have one more, which is the ability to free us from the productivity paradox, right? So the productivity paradox is we have all these great technologies, but if you look at GDP on a log plot, it's a straight line, right? And the only thing you can notice is the Great Depression and World War II. Otherwise, straight line. Personal computers come in the 1980s. You'd think productivity would jump. You don't see it. And my interpretation of why that happens is basically Amdahl's law, which says if you increase by 100-fold a portion of the work, then that's great there. But if there's a portion that you can't automate, now you're limited in how much the overall productivity gains. And so, we made spreadsheets, which were fantastic for part of the job, but then there's this other part of the job that they didn't automate at all. And I think the AI we have now is the first technology that really has this capability to do the whole job rather than just do part of it. And then we may see these productivity jumps.
Cool.
Yeah, and on that note, I think this technology is just unlocking the ability to rapidly prototype, to rapidly create. And ultimately, if you're the creator and you're directing these systems, if you are taking a digital whiteboard and drawing the app you want, and suddenly it becomes your app, and you get to use that app, it's yours. And I think the output, the creative output that this is unlocking, as well as giving anyone the ability to code with a visual interface, I think we're just going to allocate our time differently, and I think we're going to have wildly customized tools, and I think that generalizes cross industries. So just the way that I personally use this technology, it's here and there and it's everywhere. It's one-off things. I no longer treat some types of code as the need for a repository and to think with best practices. I just throw it away now when I'm done with it, but I have this massive short-term unlock from it. And so I think a whole lot of workflows can be redesigned around this, and they're going to become incredibly personable.
Cool. Well, we're nearing the end of the panel, but the panel is just the beginning for the speaker breakouts after the next one. So what is one thing where you're just like, damn, why didn't we talk about this on this panel? Or I would really like to discuss this so that people can find you afterwards in the speaker meet and greets. Give us one sentence.
I mean, look, if you're interested in AI alignment, safety, compliance, red teaming research, I'd love to talk. If you have an enterprise use case where the AI does not meet your compliance standards right now, I'd love to talk afterwards. And if you're watching this, shoot me an email, nathan@nathanlile.com, something like that.
I'm going to get weird with this. I would like to have talked about or to talk about a practical theory of artificial superintelligence instead of a purely speculative one. What are the actual, what does this actually look like as a machine? Not as, we accidentally invented God and here are his properties. I would like to understand the engineering and real mathematical characteristics of such a system. But
would love to talk about anyone who applies a strategy lens to where AI is going. That's the way we think about it, is there are many possible worlds, but some of them we can design. And so we've attempted to do that since the National Commission on Artificial Intelligence. We're doing it in our project. That's why we're situated in DC. But we're trying to convene the thought leaders from around the country who want to participate in tech strategy. And so if that's you, that's my one sentence.
Talk to me about AI for education or education for AI.
For me, it's AI and its effect on civil liberties.
Say again.
Civil liberties.
Wonderful. Yes. Thank you so much. And maybe in the past few minutes of this panel, let's look at a few of the manifold questions to inspire you to also predict on a few others. If you could have the screen up for a second, that would be wonderful. We have a lot of them on this topic, so I'm only going to maybe highlight 3. Let's see. Okay, so first one, the chance that AI has a positive impact on the future of humanity is extremely good, unbalanced good, neutral, unbalanced bad. Most people think it's unbalanced good. Well, that is really quite encouraging here. Next one up, we should explore this cryptography, security, or auxiliary area more for AI safety. So here we're mostly talking about a few Foresight focus areas that we've explored and a few of our research workshops. And zero knowledge proofs is winning. I wonder if that's because some people may not know what all the other wonderful, beautiful technologies are. But homomorphic encryption, differential privacy is also coming pretty far ahead. This one here is which risk of AI is most concerning, and most people think misalignment is really the most concerning, over abuse and accidents. And finally, a question that we also, I guess, talked about a little bit, AGI will more likely resemble a multipolar than a singleton scenario, and 65% think that will be the case. So take that for what you will. Please continue to vote and to bet and to add your manifold predictions as well. Thank you so much. This was a really, I think, insightful panel. I think really balanced. Thank you so much for joining. And please don't run away, because I'm sure many people will want to meet you after the next panel. Thank you so much.